I'm Anil Kumar. In this video, we'll understand how to develop a relationship using two variables. The question here is, Sam builds chairs and tables. It takes him 3 hours to make chairs and 5 hours to make tables. Graph the relation to represent situation for 40 hours a week. You can always pause the video, answer the question, and then look into my suggestions. The first step should always be to define the variables. Now we are talking about making chairs and tables. So let C represent number of chairs, okay? And T represent number of tables. What we are given here is that time taken for chair is 3 hours. So for each chair, time taken is 3 hours, and for each table, it is 5 hours. So chairs are made at the rate of 1 per 3 hours. So it is 1 in 3 hours. As far as the tables are concerned, we are given 1 table in 5 hours. So that much of information is given to us. We are also given that there is a week in which Sam works for 40 hours. So we know total time equals to 40 hours. So this is the information which is given to us. What do we need to do? We need to graph the relation to represent situation for 40 hours a week. Now what will that mean? It really means that in 40 hours, how many chairs and tables can Sam make? Right? All possible combinations. That is what it means. So basically, we have to graph and figure out how many chairs and tables. So we know both chairs and tables should be whole numbers, correct? They cannot be in fractions. So in 40 hours, whatever is completed will be counted as a chair. Something which is not completed will not be counted as chair or a table, okay? So first thing to decide is, we have two variables, C for chair, T for table. Which one should I make dependent? Which one should I make independent? And which one should I make dependent? In this scenario, it doesn't really matter. You could choose any. Now since it takes more time it takes 3 hours to make chairs and 5 to tables, we'll put tables on this side so that we have less numbers to begin with. Okay, so we'll put T on this side and chairs C on the other side. And to graph, we actually need a table. So let's make a T table for the scenario. Okay, so let's try to start with a T table. So we're just approaching, and then we'll figure out like how to do what. Okay, so we say we'll put tables here and chairs here. How are they related? That's a big question. The relation is that we have 40 hours. We take 3 hours to make chairs, 5 to make tables. So we know the total time. So we can say week, let's call this total time in a week, W. Let's call it W since I've already taken T for tables. So we say that 40, which is W, is equal to 3 times the chairs plus 5 times table. Because time taken to make T tables will be 5T, time taken to make chairs, C chairs, will be 3 times C, and total time which we have is 40. You get an idea. So that is how this equation is kind of connected. I hope that makes sense. Okay, now I actually chose table on the x-axis, which can make my job difficult. Let us see how. If I write that Sam makes no table, 0 tables, then how many chairs can he make? He can make 40 divided by 3 chairs. Oh, that's a fraction, correct? So what I will do here is, first step, I will rearrange my equation. Okay, I'm not still changing my independent and dependent variable. I'll go with this. Okay, we'll use calculator, right? So let me isolate the number of chairs. So we can write here that 40 minus 5t is equal to 3 chairs. And when we divide by 3, we get 40 divided by 3 minus 5 divided by 3 times t is equals to chairs. So now we know that chairs could be written as 40 divided by 3 minus 5t divided by 3. Okay, so that is the relation which we have. Okay, let's try to work with this relation and find the number of chairs. So let me write C as equal to 40 minus 5t. Let me write like this: 40 minus 5t divided by 3. Is it okay? It's like common denominator. Like, consider this statement. Is it okay? So we'll calculate. However, C should be a whole number. So C belongs to, we write belongs to whole numbers, W. Okay. So that is our number set which we are dealing with. So number of chairs should be a whole number, right? Okay. So let's use calculator since there are a lot of fractions involved. If I write t as 0, we have 40 times, we have 40 minus 0, which is equals to, divide by 3, will give us 40 divided by 3, or 13.33. Since 13.33 gives you 13 wholes and something incomplete, maximum we can make 13 chairs. You get an idea. So in this particular case, we cannot write decimal values since that will be considered incomplete chair, right? So the whole number only will be treated as a completed chair. Now if I write 1 here, then I can replace t with 1. So we get 40 minus 5 times 1 equals to, divided by 3 equals to 35 by 3, which is 11.6. So that gives me number 11. If I write 2 here, I get 40 minus 5 times 2 equals to, divided by 3 equals to 10. So this we get as 10. If I write 3 tables and continue doing so, I'll get different values of C, right? So maximum, how many can I go for? If C is 0, then T could be 8, right? So for 8, I could get 0 chairs. For 8, I could get 0 chairs. So if I continue this table, that is the kind of data I'm going to get. All these values which I have here are combination of our solution set. That is our solution. So when we say the number of tables created is 0, then we say we created 13 chairs. So let this represent 13 for us. Okay, let me write 13 here. 13 chairs. And let us say if no chairs are created or built by Sam, then he is able to build 8 tables. Let's say this is 8 tables. This is 8 tables. In that case, line joining 13 and 8, which represents the linear equation, becomes the solution, right? So let me just join this line. Now I'm joining this line with a dotted line mainly because we have whole numbers as our solution. You get my point? So at 1, we are expecting a value of 11. At 2, we are expecting 10. These points are very close to the line. They may not be exactly on the line since we have a remainder, right? So in this case, we have a remainder. Let me write here. Since we have a remainder, our points are kind of close to this line, correct? And therefore, it is a good idea to show it in terms of a dotted line. So we are saying that all these points represent number of chairs and tables combination, and they can always be whole numbers. Is it okay? So that is the solution of the given situation, that Sam in 40 hours could make 0 tables, 13 chairs, 1 table, 11 chair, 2 table, 10 chairs, and then 8 tables and 0. You can calculate all middle values by using the relation chairs is equals to, with a common denominator, it will be easy, 40 minus 5t divided by 3, correct? So here you will find that we have a restriction, and that is that number of chairs, that numbers are only whole numbers. The remainder indicates extra time when something incomplete was produced. Is it okay? So within 40 hours, completed number of chairs and tables are shown in the graph. So we say chairs versus tables in 40 hours, right? And these are number of tables. We say just in numbers, right? So we'll just write number of tables, and here we write number of chairs. Is it okay? So that is how we can actually graph the given situation. Now in this particular video, I want to highlight that when we are solving these kinds of equations, thinking about the number set, what kind of answer are we going to get, helps to provide correct solution. So here in the given situation, whole numbers is our number set. We have to write all the number of chairs and tables as a whole number. So that is very important to understand. I hope you understand and appreciate it. Thank you and all the best.